Lesson 2, Trigonometry of Acute Angles. First, let's begin with a review. Radian angle. Let's go directly to the core of this concept right here. This is a nice angle, but this angle exceeds 270 degrees, so it goes all the way like this. A bit too big for this lesson because our attention here, our focus of attention here is an acute angle. Here we go. Okay, and the other circles are all okay. It's just that this picture fits our purpose a little bit better, at least for this particular lesson. Okay, here we go. We have a circle of radius r, which is x squared plus y squared equals r squared. And r can be arbitrary, so you can have various r value. Here's one small r value. Here's another bigger r value. Now, how do we define the angle? Angle theta, or the radian measure of the angle theta, is defined by the ratio between the arc length and the radius. And with a bit of an algebra, we can rewrite it like this: S equals r theta, and the latter we often call the arc length formula. But this is a definition of the radian measure. And look at this picture down here. We have two radii and of course two arc lengths. Bigger arc lengths divided by bigger radius versus smaller arc lengths divided by smaller radius. We end up with the same angle theta, which is visualized right here. Another way to look at the same thing, S and R are both lengths. So they are both one-dimensional quantity. As you can see, S and R are directly proportional. We don't see any powers, do we? And the angle theta can be considered as the proportional constant between the two. That was a quick summary of entire lesson 1. And here's the formula again. One more thing. Angles are always measured counterclockwise. So if you measure it clockwise, then that's just a negative angle, just going backward. Okay, that's enough for the review. And let's go over to the trigonometry of acute angles. Ready, everyone? Okay, here we go. Trigonometric ratios of acute angles. Why do I call them ratios? Well, look at these definitions. They're all ratios. Y over R. Interestingly, I didn't give algebraic expression. Maybe I forgot. Okay, finally, this definition is complete. Sorry about a bit of a confusion. Now let's come back to the term ratio, trigonometric ratio. We have 3 standard trigonometric ratios, which we call sine, cosine, and tangent. This is sine, S-I-N. This is cosine, C-O-S. And finally, tangent, T-A-N. And they are associated to this kind of picture. We have an acute angle, as you can see, in the first quadrant of the picture of the unit circle here. And the angle we are interested in is the lower left-hand side corner angle. And that is also the center angle of the sector, which is highlighted in blue. Now, we have blue sector and also red triangle. And here, let us focus upon red triangle, which is a right triangle here. This is 90 degree here, or in radian measure, pi over 2. Now, sine is defined by y over r, which is opposite over hypotenuse. Angle is over here at the center. The opposite side is y, vertically going up. And hypotenuse is the radius r. How about cosine? Here we go. Adjacent over hypotenuse. What's the adjacent of this angle theta here? That's horizontal x, which is going to the right. And hypotenuse is the radius. So we have x over r. Finally, tangent is opposite over adjacent. In this picture, opposite is vertical y and adjacent is horizontal x. So we have y over x. You really have to remember all these. Now, how about the other three trigonometric ratios? As I de-emphasize in gray, they are far less important for our purpose. Why? Cosecant is nothing more than the reciprocal of sine. Sine is opposite of hypotenuse. Now if I flip it over, then we have hypotenuse over opposite. That's cosecant. How about secant? Hypotenuse over adjacent. That's coming directly from cosine. Adjacent over hypotenuse. And just flip it over. Take the reciprocal. Same for cotangent. Opposite over adjacent versus adjacent over opposite. In the end, we end up with the following relation. Cosecant of angle theta, the center angle, is 1 over sine of theta. Secant of theta is 1 over cosine of theta. Finally, cotangent of theta is 1 over tangent of theta. And there goes the relationship between the standard trigonometric ratio, sine, cosine, and tangent, and the reciprocal ratios, cosecant, secant, and cotangent. Let me sacrifice the size of this picture a little bit so that I can put everything in the same viewing window. Okay, here we go. The grand conclusion. When the angle is between 0 and pi over 2, or equivalently between 0 and 90 degrees in DMS measure, the trigonometric ratios are defined as follows. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Those three are important, three standard trigonometric ratios, which are pictured here, sine, cosine, and tangent. Okay. And then cosecant, secant, and cotangent are just reciprocals. As we see down here, cosecant is sine over theta, secant is cosine of theta, and cotangent is 1 over tangent. 1 over sine, 1 over cosine, 1 over tangent, respectively. Here's everything reviewed in a single viewing window. This is where I'm going to stop the first segment of this video lecture.